All right, you AP Environmental Science students, this is going to be your first go with your Chapter 1 lecture, right? We're starting the year off and going to start delving in to what this course is all about, all right? So you're at home and you're hearing my voice again, even though you had to hear it earlier, all right? Anyways, Chapter 1, Introducing Environmental Science and Sustainability. Mainly what this chapter is going to be about, just an FYI here, is just some really key lenses through which to view what we talk about, right? And by lens, like how are we going to approach environmental science? What type of lens do I want you guys looking through? And some key terminology. All right, we're going to bring up some things that come up again and again throughout the year in our other units as we get more specific. Okay, so let's kind of set the tone here a little bit. We live on Earth, right? And the Earth itself, right? Is the best data we have, the best information we have. If we go back to the fossil record and use some pretty reliable dating methods, we've got life on Earth for about 3.8 billion years, which is a really long time, and our human brain really isn't able to comprehend what 3.8 billion years actually seems like or looks like. But it's a long time, and interestingly, if you really look at that fossil record, it's really the last half a billion that most life things have happened. All right. Now, why the Earth and not other planets? Well, it's because it's well suited for life, right? We've got water, covering 3/4 of the planet, right? We have a habitable temperature. So at least most of the planet, the temperature stays within a range that life can tolerate. Part of that is because we have this moderate amount of sunlight. We have an atmosphere that filters out some of the really nasty types of sunlight that would fry our skin and probably make life impossible. We've got the right mix of oxygen and carbon dioxide. Some of that happens because of certain types of living things. And then we have this soil layer that provides essential minerals and nutrients for plants. And we're going to learn about the balance between those things and why each little bit and part of this system is important. But, this is just putting things in scope for you. Now, what you do have to understand, though, is that we are altering the planet in ways, right? There's a lot of people on the planet. And we're making changes. We're making changes to the chemistry of the atmosphere. We're making changes to land and to water. And some of those, by the way, not everything we do is bad, okay? But some of the things we do, we're altering the planet, not in a positive way. And so what we're going to focus on really is the human interaction with the Earth, right? How is the human force changing the Earth, all right? Now, first of all, you think about the Earth being this enormous place, and relative to you and me, it is big, but none of us are going to explore every square inch of this planet. That just isn't going to happen, right? So we've got a big planet, lots of water, lots of atmosphere, but we also have an enormous population. Right now, we're over 7.3 billion people, right? And that population is growing at a pretty alarming rate. All right, and the reason this is alarming is this is all stuff we'll get to. Like we're just kind of get some information out to you guys right now. Okay, now during this century, we are expected to add several more billion. Right, so if you look at our little graph over here, we got us up at around 7 billion people. We're somewhere around this mark on the graph, right? By 2050. Now, most of us, including me, I might be an old fart by then. Will still be alive around that time. And then it's also worth pointing out, what do we see happening to the slope of that graph? It looks like it's starting to level off a little bit. So that's another thing, is population scientists are expecting the population to begin leveling off during this century, probably while many of you are still alive. And that's an interesting prospect in itself. All right? But most population scientists, most environmental scientists predict that this rapid increase that we see in population here is going to have an adverse effect on living conditions, all right, without some really major technological advances. Okay? So we got over 7.3 billion people. Let's zoom in on the human population, right? And because not every living person interacts with the Earth in the same way, all right? So first of all, if we look at the overall global population, about 1/4 of the population lives in what we call extreme poverty, all right? And so in this case, we have to contrast a little bit with the poverty we see in the U.S. Not the poverty in the U.S. It's non-existent. It's not this. All right. So what we see in this picture here, right? This is what we call extreme poverty. So it's not simply a matter of they don't have money to get the food and clean water they need. It's a situation where the infrastructure in some of these countries, right, isn't able to get food and clean water to all of its people. All right. So we could have a homeless person on the street in the U.S. and they can go find clean water, right? If they can scrounge up some change, they could go get some food, all right? Not that that's an ideal situation by any means, but these people right here, they can't just go to the grocery store with some change they bum off the street. That's just not an option for them, okay? And likewise, they can't just go find a spigot with clean water because maybe their country or the city they live in doesn't have that available to them, all right? And so the other thing to think about is standard of living. What is your standard of living in terms of are you wealthy, middle class, whatever? And how does that relate to the consumption of resources, right? So because when we look at a global population and the ability of that population to live on the globe, really, if we look at this objectively, it comes down to what resources are available and in what quantity and in what quality. Okay, and how is standard of living going to affect that? All right. So obviously, we have highly developed countries. So this should not be new information to you guys. So we're talking about places like the U.S., and Canada, and Japan, and pretty much all of Western Europe, right? They've got nice industrial base, pretty high functioning economy. Okay. Interestingly, it's these countries that have a low population growth. Right, the rate at which they're growing is much lower than less developed countries, which is kind of counterintuitive. Why that is, again, that's a topic for later on, but it's an important fact for right now. And then, of course, along with that high functioning economy, the per capita income tends to be really high. Oh, by the way, per capita, that means per person, and that's a really there's a little R in person, isn't there? That's an important term, by the way, in environmental science, okay? Per capita means per person. So on average, we've got pretty high incomes in places like the U.S., Canada, and Japan compared to those less developed countries, right? So we contrast that. We have low population growth. In our less developed countries, we have a really, really high fertility rate. That means per female, we're looking at fertility rates of an average of 6 to 7. That means 6 or 7 children born per female on average. All right. Now, we tend to also have a high infant mortality rate, but it's in these countries, these less developed countries, interestingly, that most of our population growth is going to occur over the coming decades. Right. And part of that is this number right here is starting to decrease. Again, that's a Chapter 9 topic, but important fact for right now. All right, so we've got what our population looks like. We've got highly developed countries. We've got lesser developed countries, right? And they're going to interact and consume resources at different rates, all right? Now, what types of resources are we consuming? What are the quality of those resources is also important. So some important terminology in this, right? Is renewable versus non-renewable. Okay, so now one thing I want you to think about in this regard, though, is we are on a spectrum, really, right? So we have renewable resources like solar energy, for example, which is what we pretty much call completely renewable. We're getting a massive influx of solar energy every day, right? So if we kind of think about this as a spectrum, to completely renewable and completely non-renewable, right? Solar energy is going to be somewhere down here. Okay? Now, things like soil, though, on the other hand, right? We're not getting a massive influx of new fertile soil every day, right? And that takes time, Okay, fertile soil can renew itself, but it takes on the scale of years as opposed to a 24-hour period. So we might put soil on the renew. So if this is kind of my cutoff, right, for renewable and non-renewable, soil might be kind of over here, right, where yes, it is technically renewable. Water is kind of the same way, right? Probably a little bit faster on the water. Okay, renewable, but not as quickly as solar. So it's possible to deplete soil and good soil faster than it regenerates, and that's an important thing to consider, right? Then we can go over to things that are non-renewable, right? Now, things like coal, oil, and natural gas, those are fossil fuels. There are natural ways for those to form, right? The trouble is it takes millions of years, and so that is not a realistic timeline for us to regenerate the oil and the coal and stuff that we're pumping into the ground. Natural gas, actually, methane in particular, does form relatively quickly, but again, not quickly enough for us to regenerate what we're using. So we put our fossil fuels, over here on the non-renewable side because, yes, technically they could regenerate, right? But we're talking over time periods that are not realistic or beneficial to us. Now, things like metallic minerals, gold, and tin, what we've got is what we've got, right? We're not going to get more gold and more tin added to the earth, right? So what we use, so we're going to put that way over here on the pretty much entirely non-renewable side, okay? So this term, overpopulation, there's some controversy surrounding this, and part of what we'll do in class is we'll explore that controversy a little bit, and we can have some really rich conversations about this, right? But how do we define overpopulation? What does that actually mean? In fact, there's two ways of looking at this. One is we have what they call just people overpopulation, and this is how the term gets thrown out there a lot. But essentially, it just means too many people in a given geographic area. All right, and that's a problem in many developing countries, by the way. So essentially, we go back to those resources that we need, like soil and water and energy, right? That if a particular area doesn't have enough of those things to support the people living in it, right, we call that people overpopulation. That means there's just not enough clean water for the people to survive off of, okay, or to survive well at least. All right. Now we can contrast that idea with what we call consumption overpopulation, which is what we talk about more in our highly developed countries. Okay, and so the U.S. is a great example because the U.S. is very large, and we actually have lots of open space, lots of fresh water, lots of natural resources like timber and so on. Okay, so if we were to live very meager lives in the U.S., right, and not consume much, we have plenty of fresh water and energy and timber, etc., to go around. It's not a problem of running low on those things for us if we're very careful. Now, the thing is, though, that because we are a highly developed country, we consume too large a share of the resource. So we're using resources at a rate that are way beyond what we consider necessary for survival. And those are the things that we add to our well-being, like having a bigger house, with multiple bedrooms and swimming pools and driving to the grocery store and throwing food out that we don't eat. All these things that are kind of wastes built into our system contribute to us using way more resources than is necessary. Not that it's bad, all right? It just contributes to what we call a consumption overpopulation problem rather than people overpopulation, all right? So the last topic for lecture 1 here is this idea of an ecological footprint. So what this does, this takes into account the available resources, okay? It takes into account the size of the population, and then it also brings into this idea of the degree to which each person is using resources, okay? So we define ecological footprint as the average amount of land, water, and ocean required to provide a person with all the resources they consume, okay? And so this is where some objectivity comes in with overpopulation, all right? So if we looked at Earth's productive land and water, so what we're doing is we're taking out the open ocean, okay, where we don't get much from. We're taking out extreme deserts and places like Antarctica and Greenland that are covered with ice and are tundra, right? Places that really aren't going to support more than just a few individuals at a time, all right? Places we can't really grow crops, for example, right? We take that entire area where we can grow crops, where we get a plentiful water supply. We have 11.4 billion hectares available to us, right? By the way, a hectare is 100 meters by 100 meters, right? So 10,000 square meters, essentially. 1.5 soccer fields maybe is how we look at that, or 2 soccer fields, I guess, okay? So we have 11.4 billion hectares, right? So that's more than 1 hectare per person, all right? In fact, that comes out to about 1.6, okay? And we may need to update that based on the current population. But the point being, we have about 1.6 hectares available per person. Okay, so if we take the entire population, we break it up evenly, that's how much we have. 2 soccer fields, right? Maybe 3 soccer fields per person available. That seems like a lot of space. Okay? Now, what you have to understand, if we took the average footprint, so how much space is required for the average human being to meet their current standard of living, right? That number comes out to 2.3 hectares. And what we have there is created what we call an ecological deficit. That means that we are depleting resources, right? We don't have enough resource regeneration to meet this current standard. And in fact, as places like India develop and these lesser developed countries, as they develop and go through an economic transition, that number is just going to increase over time while the population is simultaneously increasing, which means this number right here, the available number, 1.6 hectares, is going to decrease, right? So if the population goes up and the consumption rate goes up, how much space per person we have is going to go down, and we're going to deplete those resources even faster. All right? So a good way to think about this, look at the U.S. Our average ecological footprint is 9.6 hectares. Holy cow. So that takes us back. If we look at the number of hectares available to us in just the U.S., right, we actually have, I think it's like 3.6 hectares available per person, right? But we consume at 9.6, which means we're taking resources from places like Canada and some of those lesser developed countries, right? Whereas India, the average person has an ecological footprint of just 1, all right? So it comes out to a relative balance that, yeah, we can support those populations on 1 planet, right? But if India just decides over time to go through that cultural and technological and economic revolution that they're actually in the midst of right now, let's say they develop and they want to have the same standard of living as the U.S., we need 5 planet Earths, which we just don't have, all right? And so I'm going to leave you with that. And you guys don't forget, there's some sections of the chapter on the study guide that accompany this. Highly, highly, highly recommend you read those because there's some supporting information that I think will be helpful, all right? And when you guys walk in the door, we are going to process some of this information, all right?